Hello everyone, and welcome back to my SP2 channel. We're going to be looking at the effect of non-bonding electrons and how this is actually affecting the shapes of the molecule. And I'm also going to show you a couple of practice at the end. Okay, so in our previous lecture, we talked about Vesper shape, right? Vesper model. If you want, you can go back to that video. We'll try to kind of circle back to our electron domains idea. Okay, so when you're considering your electron domains, the non-bonding or the lone electron pairs are always trying to exert greater repulsive forces on adjacent bonding pairs when you compare them to your bonding electron domains. And here's a very simple picture that you can visualize that. So if you're looking at the blue area, this is the volume that is being occupied by the bonding pairs, right? The electron that we have between the two nuclei. But if you look at your non-bonding pair, you've got a bigger area on one side of the nucleus, right? This is presenting your non-bonding pair of electron. So that means this increased repulsion tend to compress the bond angles, leading to variations in the molecular geometry, even when the total number of electron domains is still the same. Okay, so let me show you what I mean by that in our practice on the next page. Okay, so consider these three molecules. You've got methane, CH4, ammonia, NH3, and water, H2O. They all have 4 electron domains, right? But they're going to have different geometries because they have different number of lone pairs. Starting by methane, that's your tetrahedral, where we have no non-bonding electrons. This will be very symmetric. That is a perfect tetrahedral geometry where we have a really wide bond angle, which is 109.5. Now, if you're looking at ammonia, this is going to give us a very different geometry known as trigonal pyramidal, right? And that is because the one lone pair is going to push the bonding pairs closer together, reducing the bond angle to 107. And if you look at water, bent, right? This would be even stronger because now we have 2 lone pairs that are exerting even a stronger repulsion, and they're going to even further compressing the bond angle. We go down to 104.5, right? So as you can see, the more number of non-bonding pairs, the smaller the bond angle is going to be. Okay, cool. I hope that makes sense to you. Thank you very much for watching this video. If you like it, always give it a thumbs up. If you want to share that with your friends, that would be lovely to me. You guys are welcome to continue learning with me. There are going to be a lot more coming up on this chapter and many other chapters in our future lectures. Take care of yourself, and bye-bye for now.